Hello, geometry students. This is a video of example 1 for geometry topic 4, lesson 3. The lesson's essential question is, how are SAS and SSS used to show that two triangles are congruent? In the end, you will be able to use SAS and SSS to determine whether triangles are congruent. And you'll also find out what those letters stand for. Moving on to the example. Explore the SAS's side angle side congruence criterion. Generalize. Consider the relationship between the corresponding parts of any pair of congruent triangles. How do the corresponding sides and angles compare? That probably could be saved for a little bit later. First, let's hear or watch this video, 2.5 minutes. Given two triangles with well, I guess they're going to read it to us, so I don't need to. Here we go.
Given two triangles with two pairs of sides congruent and the included angles congruent, verify that the triangles are congruent. Note that side RS is congruent to side XY, side ST is congruent to side YZ, and that angle RST is congruent to angle XYZ. To prove that the triangles are congruent, show that a rigid motion maps triangle RST to triangle XYZ. Translate triangle RST.
There's more rigid motions than what they show us that can show this, but we'll just go ahead with what she's going to do. Looks like she's going to translate it first.
So point S maps to point Y. To differentiate between triangles, we label the translation of triangle RST as triangle R', S', T'. Since the translation maps point S to point Y equals point S'. Now, rotate triangle R', S', T' about the point Y. So segment S double prime R double prime coincides with segment YX. Since rotation preserves length, the length of segment R double prime S double prime equals the length of segment RS equals the length of segment XY. So point X equals point R double prime. To complete the mapping of triangle RST to triangle XYZ, reflect triangle R double prime, S double prime, T double prime across line XY. Since reflection preserves angle measure and length, the measure of angle R triple prime, S triple prime, T triple prime equals the measure of angle RST equals the measure of angle XYZ. So segment S triple prime, T triple prime coincides with segment YZ. Additionally, the length of segment S triple prime, T triple prime equals the length of segment ST equals the length of segment YZ. So Z coincides with T triple prime. Because the vertices of triangle R triple prime, S triple prime, T triple prime coincide with the vertices of triangle XYZ, there exists a rigid motion that maps triangle RST to triangle XYZ. By the definition of congruence, triangle RST is congruent to triangle XYZ.
Well, the good news is they just proved it for us. And now we can use this fact that if you have two sides and the angle in between congruent to two sides and the angle in between, then you know the triangles are congruent. Here they're asking again for a rigid motion or composition of rigid motions that show that triangle UVW, which has a side and a side congruent to a side congruent to a side, and the angle in between is congruent, show that these two map to each other. And I'm just going to click to see then there's other ways. Their rigid motion, they went with a translation of triangle UVW so that point W maps to Z. Then they rotated triangle U prime, V prime, W prime so that segment U prime, W prime maps to side XZ. Then they reflected that triangle across segment XZ. Hopefully the homework problem isn't as bad as that. Hopefully you can just apply the SAS postulate or theorem or whatever it's called. Whoops, I misplaced the assignment. Here we go. Oh, it's only number 12. That's it for this video. Have a great day.